Hey, should we get started? Yeah.
Hello, yes, let's do it.
Welcome, Balaji. Thank you for having this discussion. Before we start, I just want to thank you and Ventana so much for being a great member, a great partner. Balaji and I have worked on a lot of very difficult things this year, and I'm just so excited to see what's going on with Ventana, and I have some questions for you. And I also want to thank you very much for Greg Favor. He's just stunning. He just has done an incredible amount of work for us, so thank you very much.
Thank you. So Greg Favor that Mark is talking about is our chief architect and my co-founder.
Cool.
Thank you, Mark, for those kind words.
Yeah, so should we get started with some questions?
Yes, let's do it.
So I wrote these down, so pardon me, but look, you had other startups before and you were working in other architectures. What inspired you to start something on RISC-V and why now?
Great question. I think if you, earlier today there was a keynote speech where we covered some of that, but let me just go over that one more time. I've been in the Valley for about 30 years, done several successful data center class startups. And the most recent one is before Ventana, just before Veloce, is particularly very interesting. We tried to create an alternative to x86 with a different architecture. And we did a lot of great things there. And we could achieve stuff that our hyperscaler customers care about. And as we went through the process of driving the adoption amongst OEMs, hyperscalers, and a whole host of other high-performance embedded sockets, it became clear to us there are still some key critical issues remain to be solved. And as you look at them, you could not solve those problems with the existing architectures, namely x86 or ARM. You take a look at any compute subsystem, just about anything, you'll see everything on that subsystem is going to be standards-based or open. That could be memory, that could be networking, that could be storage, I/O. Just about any aspect of a compute subsystem is going to be either open or standards-based, with the exception of the most important part, the CPU. CPU has always been captive and proprietary. And when you draw a rigid line around that block, which orchestrates everything around it, you run into issues. You can achieve things by throwing more and more transistors, but workload level architecture efficiency completely eludes. So how do you overcome it? And that's where we thought about creating a new data center class company that allows us to facilitate OEMs and hyperscalers to innovate. And that's what led to the creation of Ventana. So Greg and we did a lot of process. Greg did x86, I took it to data center, ARM data center, and we even did a PowerPC version, but then the job was not done. We really wanted to open up that CPU in a way that allows hyperscalers to innovate and differentiate. And that's what led to the creation of Ventana.
Well, that's great. The biggest question that you and I both get asked repeatedly, and we've worked on stuff together through the year, is about the software ecosystem. And over 2/3 of the work that's done inside of RISC-V International is really around software, not the ISA. And I'm curious about what your feelings are about the current state of software, of stuff that works today inside of, on RISC-V, and what's coming as we go forward.
Great question. Anytime you talk about RISC-V, an easy but lazy FUD is, ecosystem takes forever. This is what everybody says, and it's somewhat self-serving for the incumbents. You can just about create a huge hurdle of perception by saying ecosystem, that takes forever. I think it's important that we highlight how far we've come in moving ecosystem forward. I want to show you a slide here just to illustrate the point. When I first started Ventana, even before we launched the company, we really wanted to tackle this problem head on, proactively. So we started working with one of the large OEMs and have them help map out all of the key software components that they would want to see in place to productize RISC-V easily and effectively. Once you map it out, with their help, we set out to work. So even as our team was beginning to work on the microarchitecture, we had our teams working on solving the ecosystem problem. My mandate to my team is, before we do a tape out of our 5-nanometer chiplet, we need to have the entire complete ecosystem required to productize this in place. When I say in place, it's not just Ventana saying it within Ventana. We wanted to have world-class customers go out there and say, yeah, we looked at it and it works. First of all, look at this slide. The entire suite of ecosystem components you need to productize high-performance processors across use cases, they're all contained on the slide. We've done this. It's here. It's available now. It's no longer something that you got to be concerned about. So when people throw the FUD that RISC-V ecosystem is not ready, I think we should just really ask very straightforward question and say, okay, what part of the ecosystem do you think you have a problem with? And get to the specifics. And when you get to the specifics, I think they'll quickly realize it's not a huge concern. So that's where we are. So if you look at it, our entire focus has been to make sure that the ecosystem is going to be proactively created around Ventana, Veyron architecture. And I'm happy to say, again, we achieved that before the tape out. So it's fully mature.
And your customers, are they buying this?
Absolutely. Let me tell you, I want to show this slide and then come back here. This slide represents what our customer use cases are. So if you look at, go back to, first maybe I'll start here. Look at this data center infrastructure. Almost every data center infrastructure would look something like this. You'll have these layers implemented in every one of those data centers. And look at the key building blocks. You need to have in-memory database servers, app and web servers, load balancers, world-class storage servers giving performance in terms of millions of IOPS in the most cost-effective way using things like Ceph and things like that. Cache appliances, content distribution network. So essentially, everything, and then streaming media servers. Everything that you see being deployed in a typical data center must be supported by Ventana stack. That was my target to my team. That was my mandate. Let's show you how the team came through. Look at the slide. These are end-to-end. I mean, you can see horizontal building blocks that give you the basic platform all the way up to hypervisor layer. You start with our emulator, toolchain, be it GCC, LLVM, and a bunch of different firmware options, different flavors of Linux. And on top of that, we have built reference implementations of storage servers using Ceph. To do that, you need to come up with DPDK, SPDK type infrastructure. We've done that. For networking, the same thing. So having done this for storage, networking, virtualization, security appliances, and a whole host of web services, you can look at the names. I can read them out, but then self-explanatory. If you look at the chart that I showed you, the 7-layer architecture, these are the software pieces that they all run. And last but not the least, in-memory database. It's something that every data center implements. Big chunk of a data center infrastructure is that. So when you have all of this already fully ported, available on RISC-V, and more specifically on Ventana, Veyron, our hyperscalers are excited. I can tell you our engagement with several hyperscalers as well as other high-performance customers is so deep that they've already started porting some of these to their own respective specific workload instances. So that's how far we've come. And another thing we can tell you, when you talk about ecosystem for RISC-V, Sci-Fi has been driving it for a long time. And you had other, this takes a community. This was built on the heels of a lot of work that was done by the likes of Sci-Fi, Andes, and folks like that. And you've seen announcements from Microchip. So a lot of platforms have been already shipping. I heard something like 10 billion sockets have already sold.
Yeah.
So you put it all together, ecosystem is no longer a huge concern, guys. It's just that more work needs to be done, but that doesn't mean you can deploy them in meaningful sockets, taking meaningful market share starting now.
Yeah, and I've always said that the reason we're a community is because of this. It's a software ecosystem. It's too big for any one company to ever do themselves again.
Exactly.
I have a question about runway. I mean, we know if you look at a lot of the sockets that have been put out, they've been put out on things like earbuds and other like industrial controllers, video controllers, et cetera. When do you think we're going to see general purpose computing servers available to the public?
Great question. First of all, thanks to the work you have spearheaded, Mark. And you've done a tremendous job in helping RISC-V come to a point where, look at the ISA, the state it was at when you came on board and where is it at today. And before where it was and after Ventana guys got really involved with bolstering it up. With all of the extensions and all of the profiles that have been put in place, there's nothing that you can do with RISC-V if you had a core or silicon that can perform at those levels. So you really can't go into data center, automotive, 5G edge, and client type use cases unless you have a very efficient core, but that's performing at levels that's comparable to incumbent architectures. And today, with Ventana, this morning, we've announced for the first time in the world the availability of RISC-V-based processor that performs at the same level with greater efficiency than incumbents. So once you have that, plus when you have it in the form of a chiplet that allows customers to productize it quite easily, the enablers are already there. And it paves the way for customers to then say, okay, RISC-V is no longer, it's good to start there, but then it evolved into a point where it matches all of the functional feature requirements that all these different markets care about, that they come to expect from the incumbents. And when they see that from this RISC-V community and RISC-V company, Ventana, nothing prevents them from being able to productize them in those applications. That's where we are. And so for the first time, the excitement is RISC-V can do just about anything any other ISA can do in the world. And oftentimes, you may even be able to combine RISC-V with other ISAs to create heterogeneous architectures. So more innovation, more workload level efficiency, and those kinds of things can be achieved across all these different use cases thanks to having high performance CPUs and CPUs in the form of chiplets from Ventana.
And do you have a prediction of when we'll see a general purpose server out there in the world based on Ventana technology?
Great question. So when can we see Ventana in servers? Without getting into customer-specific names and details, we can tell you we have tremendous engagements with a lot of large names, and they are actively working with our hardware PDK. Our goal is to provide hardware reference designs that customers can implement in their own form factor starting second half of next year. So you will see solutions from end customers rolling out. Our expectation is starting as early as 2024.
That's great. And sort of on top of that, you have these other markets here. What are your hopes for where you see Ventana technology being deployed, like in the field, like really deployed first? What are the ones that you think are the leading edge, that are further ahead, that are going to get out there with Ventana chips?
I think I put the slide up just to illustrate the possibilities, not just possibilities, and also we have a lot of these customers already in place doing various use cases. We started with data center, for instance. If you go to automotive, just about every one of the automotive customers would tell you they need all of the data center class features, RAS, and all of the other high performance capabilities. So we see adoption happening across the board, starting from data center, moving into automotive, 5G, edge. We have a great partner called Leapfrog, who are building a chiplet to enable 5G infrastructure. So we're working very closely with them to go into those markets. Several box builders there are using those. Client is also an opportunity for us. So if you look at it, across various markets, we have pretty strong traction. I think you're going to start adoption right from data center all the way up to very high performance embedded sockets and automotives, et cetera. So across the board.
That's great. And look, if somebody is trying to decide today what architecture to use, and they're trying to evaluate it, what advice would you give them, given you're sitting here with a lot of perspective and history of watching, all the other architectures and now being part of RISC-V. What would you tell them if they're going to, make a decision today, they're going to put in an evaluation today? What advice would you give them?
Look at what happened to open source once Linux came on board. Look at what happened to open source innovation. The possibilities and all the exciting outcomes we've seen. That's what is going to happen in the hardware space. Embrace open architectures. Why? You're going to leverage the work that's done by some estimate, they're saying about 3,000 different companies are now engaged in developing software. And if you put it all together, all these different players now can take advantage of what is already out there in the open source and build their own custom version of the platform, application, product, et cetera. So don't do it all yourself. When you go into a closed proprietary architecture, you're forced to use a lot of limitations. Forced to be living with limitations. But here, you leverage what's out there. So think about how much work that's been accomplished that could be leveraged by a lot of companies. You can spin up a startup using open source infrastructure rather quickly. I think a day is going to come where you're going to be able to do the same thing with hardware because of the open ecosystem. So think open. If you're going to build a new platform, new application, think open, think RISC-V. And I'm not saying other architectures won't. They'll continue to have vital role to play. There's an opportunity for us to all work together. But if you need your own innovation, if you want to differentiate, think RISC-V.
Great. Thank you. And I just want to congratulate you on the announcement this morning, and I look forward to our further collaboration in the future. So thank you very much.
Mark, thank you so much, and it's been a great pleasure to be here. And as I told you, Ventana is a premier member. I'm on the RISC-V board of directors, and we are a diamond sponsor here at the show. Why? Because we really believe the world sorely needs an open processor architecture, and Ventana was founded to further that mission. So excited to be part of this journey, and excited to partner with you and Calista and the rest of the team. And we are on the show floor. So please do visit us, and we look forward to having more conversations with you all. Don't let anyone tell you ecosystem is an impediment. That impediment exists in some people's heads, but not in reality. Thank you.
Thank you.